Hi, Algebra 1 students. I know that a lot of you have shared that Chapter 4 is a little bit harder, and some of the topics on slope, intercept, standard form, and point slope form of a line are confusing, and you feel like you don't have enough time to learn it, or it made sense in class, but then when you tried the homework, it was confusing. So I'm making this video to go back through all these three forms of a line to clarify what we know about them, what we can use them to find out, and how to solve problems with them. So I hope this video is helpful. The notes, they are similar to the notes packet, but I kind of cut some stuff out and reordered them to hopefully make it useful for you to go back and review. So the first thing to kind of remember and focus on is all three forms represent straight lines. They're just different ways of looking at the same line. So it's kind of like a fraction or a decimal or a percent can all represent a number. There are three different ways to represent the same number. These are three different ways to represent the same line. So slope-intercept form is the one that you're most familiar with because most of you should have covered this last year. Not everyone, but most of you. So in slope-intercept form, you have a slope, which is the m value, the number in front of the variable, and the b value, which is the y-intercept. The second way that you can write a line is called point-slope form. So why do we have two of these? Slope-intercept form requires knowing the y-intercept specifically. So what if you know a different point that's not the y-intercept? Instead of having to solve and calculate the y-intercept, you could just write the equation using any point. But the form that you have to put it in is a little bit more complicated. It's got both an x coordinate and a y coordinate because you're not just on the axis. You could be any point anywhere. So in this form, y minus y1 equals m times x minus x1, you have to recognize that the x and the y are the coordinate point that you have. When you plug them in, you got to be using those minus signs. So if the x coordinate is positive, you're going to write x minus whatever that number is. If the coordinates are negative, when you subtract the negative, it switches and becomes positive. The last one is standard form. So standard form does not include the slope, and it does not include any intercepts or any points. So it's just a form where you put the x and the y together on the left-hand side of the equation, and you can't have any fractions or decimals in these a, b, and c values. So in a few minutes, we'll cover how to convert into standard form. But one of the first things you have to do is multiply the whole equation to get rid of any fractions that you have. Okay, so let's clear and scroll down. So what about slope-intercept? Kind of a deep dive and reminders for slope-intercept. In slope-intercept form, your rise over run is your slope. So if you're given a graph, you can find the rise over run by just counting. And if you are given two coordinate points, you can find the slope using y2 minus y1. So I'll say or y2 minus y1 over x2 minus x1. So you can calculate the slope if you're given points. You can calculate the slope if you're given a graph, or sometimes the problem will just tell you what the slope is. Then what about the y-intercept? So the y-intercept is what you're going to plug in as the b value right here. And sometimes the problem will give you the b value, and sometimes it won't. Sometimes you have to solve for b by plugging in the information that you know. Okay. Anytime you ever need to set a problem says convert something into slope-intercept form, converting into slope-intercept form is exactly the same as telling you to solve for y. So if they give you the equation in some other form and they say convert it in, just whatever you have, solve for y. Same thing you've been doing before. Move everything else away, add or subtract, move terms to the other side, and get y by itself. Once you've done that, you'll have the equation in y equals mx plus b form. You can identify the slope, you can identify the y-intercept, and you can graph it if you need to. When you are trying to graph it, the way that you're going to graph it is a two-step process. You're going to first graph the y-intercept. So plot the point for the y-intercept on the y-axis, and then count your rise over run, whatever the slope is. So look at the slope. If it's, for example, 3, go up 3 over 1, up 3 over 1. If the slope is negative, you're going to go down and over, down and over. So graphing from slope-intercept form involves, again, plot the y-intercept, follow the slope. Okay, now, how do you actually solve problems? We're just going to jump straight to an example. And so this is going to show us how do you find the slope, how do you find the y-intercept in an actual example. So let's clear and scroll down, and we'll do an example here. Okay, so find the slope of something that goes through these 2 points. Well, First of all, if you have to graph it, it's super easy. Just graph these 2 points. So over 4 down 2, and we will label a 4 and a -2. Then -3, 1 is back 3 up 1 right there. And now we can draw a line that goes through these 2 points. Try to draw it as straight as you can, like that. So graphing, like I say, if you're given 2 points, graphing should be really easy. You plot the 2 points and you draw the line that goes between them. Solving for the actual equation might be a little bit more work. So we know we want slope-intercept form. So we first write y equals mx plus b. Now, we don't know the b value, but we do know the slope. No, we don't even know the slope. So we're going to have to do two things. We're going to have to find out the slope, and then we're going to have to find out the y-intercept. So before we can fill anything in, we need to find the slope. So I'm going to write slope equals y2 is 1 minus y1 is -2 divided by x2 is -3 and x1 is 4. So in the numerator, the negatives cancel out and it becomes positive. And the denominator, they're both negatives. They combine to -3/7. So now we know the slope is -3/7. So over here in our equation, y equals mx plus b, we can plug in the slope as -3/7. And we need to figure out what b is. So we're going to have to plug in the x coordinate. And we can pick either one of these points. So it looks to me like I'm just going to choose the first one, 4, -2. So I'm going to put a 4 in for x, and I'm going to put in a -2 over here for y. And then I'm going to put plus b. So it looks kind of nasty because we have a fraction, but this is something that we can solve for b. So we just simplify our fraction. -3/7 times 4 is -12/7 plus b. Now to solve this, I'm going to have to add 12/7 to both sides. Add 12/7. And you can use a calculator, or you can just kind of think about -2 is like -14/7. So if I add -14/7 plus 12/7, I'm going to get -2/7. So I'm going to get b equals -2/7. You can take, now we got both pieces we need, right? So big pictures, take a step back. You always have to find the slope, and you always have to find the y-intercept. Once you have slope and intercept, you can write the equation in y equals mx plus b form. So I'm taking this slope, -3/7. I'm taking this intercept, -2/7. And I'm going to write y equals mx plus b. So the slope, -3/7. We always have to, don't forget your x variable. So there's an x right there. And then -2/7 is the y-intercept. You can also look at your graph and verify that this makes sense, because on the graph, this line that I drew that goes to the points, it's just a tiny bit below 0. So a y-intercept of -2/7 makes sense and matches what we see on our graph. So again, you have to find the slope. You could do that by counting on the graph, or you could do that by using the 2 coordinate points and doing the equation y2 minus y1 over x2 minus x1. Next, you have to find the y-intercept. So you can plug in the slope and a point that you know into the equation, y equals mx plus b. And then once you plug in x and y and m, you can solve for b to get the y-intercept as a number. Once you have the y-intercept and the slope, you plug them into the equation and you have your final answer. You can look at the graph to verify that it makes sense. The slope is down 3/7 and the y-intercept matches up. Okay, moving on to point slope form. Point slope form is typically a lot easier because you don't need to worry about calculating the y-intercept. You can take any point and just write the answer. So let me clear the screen and scroll down. All right, here we go. Point slope form. Point slope form is very, very nice if you have to find an equation and you know one of the points. So in this case, it says we know these 2 points. So once again, more practice of the same thing. Plot these 2 points. Go over 5, up 4, put a dot, label your axes. And the second point is -3, -2. So go back 3, down 2, put a point, label your axes. And now draw a line as best you can through those. Sorry, my line is not super straight because I'm using a mouse, but it helps us visualize the line. So these are the 2 points that we used to draw the line. But we know it has a positive slope. and we're going to find the slope. So before I found it by doing y2 minus y1, on this one I want to switch it up and find it by just counting. So to get from this point up to this point, I can just count 1, 2, 3, 4, 5, 6. So I went up 6. And now let's see how far over I have to go. 1, 2, 3, 4, 5, 6, 7, 8. Over 8. So you can get your slope using rise over run on the graph, or you can get your slope by using the equation with the y2s and the y1s and all that. Either way, you got to reduce your fraction. So 6 over 8 reduces to 3/4. We can do a quick check common sense. It's going up and to the right, which means it's a positive slope. Once I know my slope and I have a point, I can pick either point, doesn't matter. I'll just pick 5, 4 as my point. I have a point, I have a slope. There's no more work to do. That's why point slope form is so nice. I can just write the answer. Y minus y1 equals m times x minus x1. So we're going to plug in the m, which is the slope, and the x1 and the y1, which is our point 5, 4. So it's as easy as this. Y minus 4 equals m, which is 3/4, parentheses, x minus the x coordinate, which is the 5 right here. We put a box around it, and we are done. So you can see that finding the equation in point slope form was quicker and easier than finding the equation in slope intercept form, which is why we use this. Okay, so take a pause, look back through, see if it all makes sense. Plot the points, draw the line through them. That gives you the equation of the line. And then count rise over run to get the slope, or use the equation if you want. And then once you have the point and the slope, you're ready to write the answer in point slope form. Okay, just one example left, and then we were done with our review video. So again, clear the screen, scroll down to standard form. Okay, so standard form is the one that doesn't have a slope, doesn't have a point. It's a little bit kind of weird and unique. Standard form is not used as much for graphing and is used a lot more for solving word problems and systems of equations. So how are we going to take advantage of that? Let's get started. Standard form always has the x term first, the y term second, then the equal sign, then the number by itself on the right. Also, we can't have any fractions, decimals, or percents. So if we have anything like that, we need to multiply the entire equation to get rid of fractions or decimals. And the last thing is it has to start with a as positive. So if you get to what's like you think it's the end and a is negative, you just multiply the whole equation by -1. So that's basically what I just said here. Clear fractions. If you ever need to find the slope and you have something in standard form, you're going to convert it into slope-intercept form. If you convert it into slope-intercept form, it's now going to look like y equals mx plus b. And you can get the slope by looking and saying, okay, what is my m value if I did that? It's the number in front of the x. So just solve the equation for y, and you can instantly use that to get the slope. Again, what if you need to find the x and y intercepts? It's the same thing we've been doing now for quite a while. If you set x to 0, you're getting the y-intercept. If you set y to 0, you're getting the x-intercept. So we'll do some practice with that as well. Let's jump straight into our first example. Convert it into standard form. So if you want to convert to standard form, it's going to be a 3-step process. Get rid of your fractions, move the x and y to the left, clear the negative in the front if there is one. So the first thing I see is I have a 4 in the denominator. So I'm going to multiply the entire equation by 4. That means it distributes all the way to the y. So I'm going to have 4y equals, when I distribute the 4 onto the 3/4, the 4's cancel out. That's the whole point of why I did this. So what do I have left over? I have the 3 and the x left over. And then don't forget to distribute onto the 2. So I have -8. Okay, now I need to get the x value over on the left. So I'm going to minus 3x, minus 3x. And we're almost done. We have -3x plus 4y equals -8. So the a and the x are in the right spot. Look back up here at our equation. It visually looks very nice. I got the ax, the by, and the c. But the problem is a is supposed to be positive. So I have one last step, which is I need to multiply this whole equation by -1 to cancel out the negative sign. So the negatives will cancel out. In the front, I'll have 3x but the negative distributes, so it's going to change that to minus 4y, and the negative distributes all the way to the 8, so it's going to equal positive 8 on this side. And that is our answer in standard form. So just to be clear, this equation, y equals 3/4 x minus 2, the original equation right here, is identical to the new equation we got, 3x minus 4y equals 8. It's kind of like saying that a fraction 3/4 is the same as the decimal 0.75. There are two ways to express the same information, a fraction and a decimal, or in this case, slope-intercept form and standard form. Okay, let's do one more example of converting to standard form because this is a big one. Now I have a denominator here. It's a 3. I'm going to have to multiply both sides of the equation by 3. Multiply by 3. On the right-hand side, the 3's cancel out, leaving me with just 1x minus 4. So x minus 4. On the left-hand side, the 3 is going to distribute in, leaving me with 3y minus 6. Okay, as before, I have to move the x over, so I'm going to subtract x, but this time I also have an extra number here, so I'm going to add 6. Add 6. Okay, so the 6's cancel out, and I have negative x plus 3y equals, here the x's cancel out, negative 4 plus 6 is 2. Once again, I have a negative in the front. Super annoying, but we need to multiply the whole equation by negative 1 to cancel out the negative in the front. So now it's going to switch all the signs. X minus 3y equals negative 2. When you multiply something by negative 1, all the signs swap to be the opposite of whatever they were. So there's two great examples of converting something into standard form. Again, it's ax on the left, then by, then the equal sign, then the number by itself on the right. Feel free to pause the video anytime to help make sense of these, or rewind and watch it again if you missed something. And we'll just do a couple more examples and we'll be finished. So the last example, we are going to find the intercepts, then convert the equation into slope-intercept form and graph it. So to find the intercepts, I can set x equal to 0. That's going to find the y-intercept. So if I set x equals 0, I have 0 minus 3y equals 15. If I divide by negative 3, I'll have y equals negative 5. So that's my y-intercept. And then if I set y equal to 0, I'll be getting the x-intercept. So now I'll have 5x minus 0 equals 15. Divide everything by 5, and I'll have x equals 3. Okay, perfect. I can now graph the intercepts. On the x-axis, I go over to 3. On the y-axis, I go down to negative 5. And you notice that I always label. When I'm plotting these points, I always label them. Now I just have to draw a straight line through these 2 points. So again, it's a little bit rough because I'm using a mouse, but it's a straight line through those 2 points. So I can also convert to slope-intercept form. That will allow me to see the same equation using slope and intercept. So what's that going to look like? I'm going to start with the equation 5x minus 3y equals 15. And to convert to slope-intercept form, like I said earlier on, you're just solving for y. Get y by itself, move everything else away. So to solve for y, we're going to first have to get everything to the other side. So minus 5x. Negative 3y is left over here. Negative 5x plus 15. Now divide by negative 3. Be really careful here. You got to follow the golden rule. You have to divide everything by negative 3. So that leaves us with y equals, the negatives cancel out, and I get 5/3 x. Now 15 divided by negative 3 is minus 5. So here's my equation of the line. in slope-intercept form. And just like before, right, we're getting the same equation in two different forms. Previously, I started with slope-intercept and I converted into standard. Now I'm starting with standard and I'm converting into slope-intercept. We can also look at the slope-intercept equation here and say, hey, does it seem to match our graph? This is the y-intercept, and sure enough, that matches. This is the slope, and let's count up 5 over 3. If I start at -5 and I go up 5 over 3, I land perfectly on this x-intercept. So everything about this problem is consistent. It reinforces that we've done it correctly. Okay, I know, like I said, that these chapters can be confusing. It's easy to get mixed up all the different things. So, save this save this video, bookmark it, come back and look at it when you're studying, if you're going to do a retake or you want to prepare for the test. All this stuff is foundational and really important to kind of know as best you can, not only moving forward in Algebra 1, but for all of your future math classes. Everything is built off of linear functions, solving equations for x and y, finding slopes, finding intercepts, and that kind of stuff. So yeah, I'll see you guys in class, and I hope this video was helpful.